Hi, welcome to Chapter 10, Section 2. We've got a couple more area formulas to deal with. We're going to be looking at trapezoids, rhombuses, and kites. So for a rhombus, the formula, rhombus and a kite, the formula we're going to use is half d1 d2, which is diagonal 1 times diagonal 2. So in these two pictures you can see here, I also want to point out the area of the rhombus may also be the parallelogram formula. So let's make just a note about that. Area of rhombus also equals base times height, and that can come in handy later, we'll see. So in these two pictures, I've drawn a rhombus here and a kite here, and in both those pictures, you could find the area by doing half diagonal 1 AC times diagonal 2 BD. Same thing over here. Half diagonal 1 AC diagonal 2 BD. Okay, so now we're going to go ahead and look at the trapezoid formula. Trapezoid formula says that the area of a trapezoid can be found by doing half base 1 plus base 2 times height. And you will see that written out most of the time as half quantity B1 plus B2 times height. Now, we also have the secondary version that the area of your trapezoid can also be the median of a trapezoid times the height. If you recall from previous chapters, the median of your trapezoid is the average of the bases. So you add together B1 plus B2 and you'll get the median. So that's, as you can see, this portion of your formula. So in the picture, your bases, of course, are going to be your parallel sides of your trapezoid. The height will be one of the altitudes connecting the parallel bases. Notice I've drawn this lovely altitude here, but the altitude could actually happen anywhere from base to base as long as it's a perpendicular segment connecting them. Okay, so let's move on to page 2. Okay, in our first example, we are being asked to find the area of this trapezoid. So again, it's always a good idea to start by writing down the formula for the area of the figure you're looking for. And that's going to be half base 1 plus base 2 times height. So at that point, all I need to do is sub in the appropriate values. So B1 is 15, B2 is 17, and our height, our perpendicular distance between those two bases, is 7. So at that point, you break out your calculator or you take a few seconds and add in your head. And I'm going to pause and figure out what 16 times 7 is, and we'll be right back. Okay, 16 times 7 is 112. Our units are inches, so these are square inches. Okay, we're looking for the area of this second trapezoid. And you should notice that I don't have my base. I don't have the height. I just have one of the bases. But I have a lovely 30-degree angle here. So when I draw in the other important altitude, I form a 30, 60, 90 with a hypotenuse of 20. Therefore, my short leg will be exactly, it's going to be 10. Good job. And that means my long leg will be, oh my gosh, do we care? No, we don't. So this turns out to be 10. Actually, we are going to care in a second because this long leg will then be 10 root 3. And if this whole side was 24, that makes this piece 24 take away 10 root 3, woo! And that makes this base 24 take away 10 root 3. Wow, Okay, so with that in mind, let's go ahead and calculate our area. So again, we write our formula because it's a good idea and it'll help us memorize it. Then we plug in what we have. So one of our bases is 24, plus my other base is 24, take away 10 root 3. The height is 10. So at that point, I'm going to clean up inside 48, take away 10 root 3. And then I'm going to do the easiest thing, which is to distribute the 10 first. And then cut everything in half. So 240 minus 50 square root 3. And our units are centimeters, and the way we usually write that is we put parentheses around to say that the centimeter squared applies to both the 240 and the 50 root 3. So that was a doozy. A lot of good algebra going on in there. Fun times. Okay, so we are going to move on to example 3. We have a kite for example 3. So you'll also notice in that kite we have a lot of 45-degree angles, 60-degree angles, etc. So we can see here that in this 30, 60, 90, I have a hypotenuse of 12. Therefore, my short leg will be 6, and my long leg will be 6 root 3. I also know that this diagonal of my kite gets bisected, so that makes this a 6. I now just need to find the last remaining side of my second diagonal, and that turns out to also be, because of the 45, 45, 90, 6. The legs are equal. Okay, so for kites, our formula is half d1, d2. And now I can say that's half. One of my diagonals is 12, and the other diagonal is a little bit fancier. It turns out to be 6 plus 6 root 3. Okay, same scenario. We're going to clean up, and we're going to get 36 plus 36 root 3. Our units are centimeters squared. Now, I also want you to think of, and this is some homework for you, I'd like you to think of an alternative method to find this area. How else could you have approached this problem and been able to come up with the complete area of the kite? Okay. We are going to skip example 4, it's another kite, and we are going to move on to example 5 on the next page. Okay, in example 5, we're looking for the area of this rhombus. We've been told this is 60 degrees. We also know that the diagonals of a rhombus are perpendicular to each other, so this is a 30, 60, 90. With our short leg being 3. We also know the diagonals bisect each other, so this piece will also be 3. So if our short leg's 3, our long leg over here will be 3 root 3. This piece will also be 3 root 3 since the diagonals bisect each other, and I now know enough to find the area. So area equals half d1, d2. I fill in what I need. One of my diagonals is 6, and the other diagonal is 6 root 3. Go ahead at that point, multiply everything out. You should get 18 root 3. Our units are centimeters, so this is going to be centimeters squared. For this picture, I also would like for you to think of an alternate method to find the area. Can you come up with another way that we could have calculated the area of this rhombus besides using the formula that we have in front of us? Okay, the last 2 examples we're going to work on in class, so I will see you there.